So we're going to have a math lesson today, and I thought we'd start with some multiplication cards. See if you can say the answer as fast as you can. 6 times 8. Very good. 2 times 6. 5 times 9. 3 times 8. 8 times 4. 4 times 5. 9 times 3. 9 times 7. 6 times 9. 2 times 1. 7 times 7. 3 times 3. 4 times 4. 1 times 3. 8 times 9. 7 times 6. 8 times 8. 9 times 9. 3 times 2. 2 more. 1 times 5. 1 times 7. Very good. All right. And I'm going to review our classwork from last week, comparing fractions, to make sure everyone understands how to do this. So the first one that we had was 5, 6 compared to 4/5. Let me get this over here where you can see it. There we go. Now, you can multiply both of these times 2 over 2 times a fraction that equals to 1 to get a fraction that's more understandable, but we're going to work in the concrete today and compare, just so you can get a visual image in your head. So 5/6, we have that. 1, 2, 3, 4, 5. Here's 5/6. Then we have 4/5. 1, 2, 3, 4. Which is greater? Which is a greater amount? Which takes up more of the whole? Would be this one, wouldn't it? So you're going to compare with greater than. So 5/6 is greater than 4/5. And you can look at it here. Make sure you can see it. 5, 6, 1, 2, 3, 4, 5. Be right here. Then 4/5. 1, 2, 3, 4, which is a greater amount, 5/6. Okay, so we looked at a bar fraction and at circle fraction. Remember what a fraction is? A fraction is part of a whole. Let me grab my eraser really quickly. All right, so we're just going to do a few of these. What about 2/10 compared to 2/12? Okay, so here's 2/10. And here is 2/12, which is a greater amount. You can lay them on top of each other. It would be the 2/10, wouldn't it? So that'd be greater than right there. And you can see that here, 2/10 is greater than 2/12. Usually it's going to be the amount that has the higher the lower denominator, because that means that that pizza, if you're thinking about it in food, is only cut in 10 pieces. This one's cut in 12, so these are going to be a little bit larger. So that's a way to think about that. I always like to think about food when I think about fractions, because it makes a lot of sense. Let's do one more. 3/5 compared to 3/6. So let me grab, I'll put this up here. Three-fifths compared to 3/6, which takes up more space. Yeah, it'd be the fifths, wouldn't it? Because you can tell that the 3/6 is equivalent to what? You're right, 1/2. So 3/5 is greater than 3/6. And you can see that here, here's 3/5, here's 3/6. 3/6 is right at the half point, and 3/5 goes over the line. Remember that when you're comparing fractions, you need the same size wholes. You can't have a small circle and then a large circle and compare. You can't have a small bar and then a large bar and compare. They've got to be the same amount. All right. So if we're adding fractions, 1/10 plus 1/10 plus 1/10 plus 1/10 would be what? When your denominator, which this is the numerator, this is the denominator, is the same, it's going to stay the same. Then your numerator, 1, 2, 3, 4, is equal to 4/10. And yes, that can be reduced to what? You can divide both the top and the bottom by 2, and it would also be equal to 2/5. So on here we can see that 4/10, 1, 2, 3, 4, is the same as, it's equivalent to 2/5. It's the line. See, it matches. Okay. I'm going to give you a mental math problem, and I just want you to think about it, and then I want you to work it out on your paper or your board. A chef is making 14 pizzas, so I'm just going to put chef is making 14 pizzas, put P for pizza. Each pizza takes 1/6 pound of cheese. How much cheese will the chef need to make all the pizzas? So I want you to make a visual representation. So you draw it however you think you should draw it in your head. What I'm going to do is I'm going to make a bar model and make sure that you can see it. I'm going to cut it into 14 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Very good. And so for each pizza you have how much cheese? 1/6 of a pound. So I'm going to write 1/6 in each space. You might think to multiply. You might want to make circles that look like the pizza. It's totally up to you. This is yours. This is the way that I wanted to think about it here, okay? So I'm just gonna count up, since my denominator's the same on all of them, I'm gonna count up the numerators. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I have 14 1/6, and then you look at that and you think, ooh, Miss Black, that looks wrong. Because it's what? It's an improper fraction when your numerator is higher than your denominator. So what you do is you divide. 14 divided by 6 would go twice. How many left over? 2, 6. So you would have how much? It says 14 pizzas. Each pizza takes 1/6 of a pound. So now you know that for this you need 2 pounds and 2/6, or you can reduce that to 2 1/3. So for the pizzas we need to buy 2 1/3 pounds of cheese. Okay, let's move over to place value, and this is something we learned in class, but I want to make sure that no one has forgotten it. So what is this? We can say it's a dot, it's a point. If I put these over here, this is place values, and this is your decimal. Remember, we say that a decimal is indicated with and, like if you have $1 and 23 cents, that and is the decimal. What number is on this side of the decimal? This is to the right. Your right is the tenths place. So I'm gonna write 10, and then I'm just gonna add a THS, tenths. What is this one? 100. But we say it's hundredths, so I'm just gonna add a THS. Then what would this one be? You're right, 1,000. And I'm just going to add a THS. So you spell them all the same way as you spell your place value on this side, the ones, tens, hundreds, thousands, but you add the THS. So tenths, hundredths, thousandths, okay? So if we read this would be 1/10, 2 hundredths, and 3 thousandths. You can convert these to fractions, vice versa, either way. So remember this, as we're talking throughout our lesson. So if we had 2/10, how would you show that as a well, actually, before we do that, how would you show that in the concrete? Well, you could pick up 2/10. How would you show this as a representation? You would divide your circle into 10 parts. It's not going to be perfect, but that's 10. Okay? And you would shade in 2 pieces. 1, 2. So that's 2/10. That's the representation. That's the concrete. That's the representation. And then this is your fraction, your 2/10. How would you write this as a decimal? Decimal 2. That's 2/10. Means the same thing as that. Okay. Let's do a couple. Have a Singapore math book. I love Singapore math. What if we had this fraction? How would we write this as a decimal? You're exactly right. It would be 0.3. But if we had this as a fraction, how would we write that as a decimal? You're right. 0.4. Okay. It's a little bit harder. What if we had this? Don't let this trick you. 1 and 1/10. That would be a mixed number, wouldn't it? Because you have a whole and you have part of a whole. So it would be 1, it's equal to 1 and 1/10. So you have a whole and part of a whole. What if you had 2.3? That would be 2 and 3/10. That's also written as a mixed number. It's a whole and part of a whole. I'm going to give you a couple to work on your own, and then we'll check. Right. 0.3 is a fraction. 0.6 is a fraction. 3/6 as a fraction. And 1.4 as a fraction. If you need to think about it in terms of your concrete and then your representation, then write your fraction. That is great. Remember, this is your rod, this is your 10, this is your whole rod. This would be 1/10. 1/10. 2/10, that's part of the whole. 3/10. 4/10. 5/10. See, that's half. That would also be 1/2, 1/2. 5/10, 5/10 equals 10/10 as a whole. Okay, let's go over these. This would be 3/10. 3/10. 0.6 would be 6/10. 6/10. 3.6 would be 3 wholes and 6/10. Yes, you can reduce 3, divide both your numerator and denominator by 2. That would be 3/5. And then it's also going to be a mixed number, 1 and 4/10. And yes, you can reduce 1, divide both your numerator and denominator by 2, 2/5. Very good. So today we looked at fractions. You worked a word problem. Dealing with fractions, you compared fractions. And you also converted decimals to fractions, fractions to decimals. So wonderful lesson. Keep on working on these, and I will talk with you soon.